So today's quiz, we'll go over it quickly. We have a scenario here, and of course the first step is we want to create before and after diagrams. So in this situation we have mass, eastward, that's key. Eastward we usually define as positive. And we have a speed. So that's V0. The wall bounces back. That means it's going to be going the other direction, so that's going to be minus. And that's V final. Change in momentum. That's delta P. So we need to create the diagrams before and after. I suggest I should draw two diagrams. I can get away with one, but it's just as well to have two. So we have our before and our after. And the ball is thrown eastward and hits a wall. So eastward positive, westward negative, eastward positive, westward negative for before and after. Well, if it's thrown eastward and it hits the wall, that means the wall must be over here. And the initial speed then is 4.764 meters per second, and that's V0. And it has a mass of 0.505 kilograms. And afterward, we have the wall like this. It bounces back. So that means the ball's now going this way. And its speed, we are told, is 4.261 meters per second. But since it's headed westward, that westward is minus. So the velocity, the V final, is negative 4.261. So now I've drawn my before and afterward diagrams, and now I'm going to do my inventory. So my inventory, I have my mass, which is 0.505 kilograms, and that has 3 significant digits in it. My inventory is going to have the quantity, that's the mass, the magnitude is the number, the direction, mass doesn't have a direction, the units, and the significant digits. That's 3 in this case. The next thing I have is this, which is the initial velocity, which is 4.764, and that's a positive, meters per second, and there are 4 significant digits there. The next quantity I have is the final velocity, which is 4.261 is the magnitude, meters per second units, but it's in the negative direction. So it helps me see I'm going this way, so the velocity is negative. So negative 4.261 meters per second, and that also has 4 significant digits. And now I'm looking for the change in momentum. We don't know what that is. The units are going to be Newton seconds, not north-souths. And since we'd have 3 and a 4 situation here, the final answer will be 3 significant digits. So we've done our inventory, quantity, magnitude, direction, units, standard deviation, significant digits, and now we need the formula. Well, change in momentum is mass times the change in velocity. That's the formula. So we're looking for delta P. It's already solved for us. That's awfully nice. And the mass is 0.505, and delta V is VF minus V0. Change in something is always the final state minus the initial state. So we have minus 4.261 minus 4.764. So I key that into my calculator. And that gives me a change of momentum of negative 4.557625. The units are Newton seconds. So my formula, I substituted correctly. I calculate the answer. I record the unrounded answer with the units. Unrounded with units. And now I'm going to round to the correct number of significant digits. Change of momentum. Supposed to have 3 significant digits. So 1, 2, 3. So the change of momentum is negative 4.5. After this 5 is a 7, so we round up. Negative 4.6 Newton seconds. And the last step is to make it clear what my answer is. I'm going to box my answer. Negative 4.56 Newton seconds. Just so we make sure you know how to enter this in your calculator, that final answer would be negative 0.505 times, excuse me, it's not negative, negative 4.261 minus 4.764, close parentheses, enter. And therein is my answer, my unrounded answer, and I record every digit.